So if we think about the overall benefits of openBIM at that strategic level of productivity, profitability, sustainability, let's now focus perhaps on how this actually comes to life at an individual stage of the building process. So if you take the design phase, for example, on a big complicated project, you will have multiple designers in multiple countries all contributing, and risks and problems in construction happen at the interface boundaries between organizations' life cycles. So if you have design of a building and design of perhaps an infrastructure asset, a railway line converging with that building, how do you manage the interface between them? And the answer is, if you have this common language that both designers are operating in, even if they're using their own software tools which are different, actually you can then bring those two models together and you can start comparing them. So you can do clash detection, for example, and you can do that electronically in the model. You can do virtual reality training, walkthroughs, etc. But you're doing it digitally before you've actually wasted time and effort by building things which aren't compatible. So immediately you've got productivity improvements because you've got less rework, and you've got sustainability improvements from that as well, because actually you haven't wasted valuable resources in building something that needs to be redone. And the same is through later in the life cycle. This allows you to bring all of these different models together, including data from the product manufacturers, and incorporate them into a single model where you can actually then give to your facility management team, who can think about, how am I going to maintain this building? How am I going to upgrade it in 20 years' time? And you can do all of this work digitally, which saves you so much in terms of time, expense, and actually risk as well as a construction and project owner. So those are some of the examples of improvements you get at individual phases of the life cycle. You can then actually look beyond that, because there are other benefits here. There's a piece around, actually, how do I manage access to my data through the life of the program? And again, if I've got proprietary data formats, so not open standards, I've then locked myself into using that software through the life of this building. And some of these buildings that we construct now might last 50, 100 years. So actually, do I want to be tied to one particular software company for 100 years? Economically, I can see some challenges with doing that. So again, by having my data in an open format, open source software, anyone can actually access that file for me. So I can go to any software company over the next 50, 100 years, and they are able to read that software, read that data for me, and I own my data. I can access it at a much lower cost. But I can also take advantage of innovation as well. So again, if I'm tied to one software vendor, where's the incentive on them to innovate, to do better? Because actually I'm locked into them. Whereas actually what I can do if I've got my data in open format, I can pick up the best of breed of new software innovations as they come to the market. I can jump between vendors based on what they offer. So I can actually adopt innovations as they come along. And that will be really important in the future as digital twins grow, as we get into the Internet of Things, and I want to introduce more two-way sensors into my building, which then connect back into my digital twin, which is based on my BIM modeling. So suddenly that ability to adopt innovation through life is really important, and it depends utterly on having these open standards baked in from the outset of my project.